welcome all of you to my lesson. Today we are starting set theory. It is chapter 1 in the textbook of class 11. It's a basic lesson, so try to understand the ideas we explain. A set definition is a well-defined collection of objects or elements. So well-defined means we can identify whether an element is in the set or not in the set. Example, the set of letters of the word association. In the word association, you see A is there, S is there, O is there, C is there, I is there, T is there, N is there. We don't repeat the element A. We don't repeat the element S. In a set, an element can come only once. Once you say A is there, it is permanent. A is there. So capital A is the set ASOCITN. The set is represented by the double brackets like this. Now we observe there are 1, 2, 3, 4, 5, 6, 7 items. So N of A, number in A is 7. Now here an important idea, small a is an element of capital A. Is that? But B, we don't see any B there. B is not an element of A. So this is a symbol, is an element of. Now we go to finite set. A set is finite if it contains a finite number of elements. That means we can count the number of elements and stop the business. Now, the set of all Indians, you can see the number is large, but we can count out all the Indians, so it is a finite set. Now we consider infinite set. Capital A is an infinite set if the process of counting its members never stops. So if you count the number, that counting process will not stop. Example, the set of lines passing through a point, or the set of points on a line segment. Now if you have a line segment AB, points on this, infinite number of points, you cannot count the number. Null set. A set is null or empty if it contains no element. Example, set of men of age 500 years now alive. We know that there is nobody who is of 500 years age now. So such a set is empty. Or set of 500 animals. An animal has only one head. But 500 animals are none. So there is no 500 animals. Now singleton set. If a set contains only one element, but there is singleton set. So singleton set. Example, set of fathers of a child. There is only one father, so it's a singleton set. We consider set operations. 1. Union. Union of two sets A and B is the set containing elements of A or of B or of both. And it is denoted by A, U, B. This is the symbol for the union, A, U, B. Now example, A is 1, 2, 3, 4 set, B is 4, 3, 5, 6, and C is 6, 7, 1. Then A union B, we are comparing this. Every element of A will come there, 1, 2, 3, 4. Then elements of B will come there, but 4 and 3 are already there. So 5 and 6 come. So elements of A or of elements of B or elements of both. Now A union B comes. Similarly, A union C, you can see. A union C, 1, 2, 3, 4, together with 6, 7, 1. So 1, 2, 3, 4, 6, 7. Now A union B union C. The whole of these, A, B, C. 1, 2, 3, 4 comes, then 5, 6 comes, then 7 comes. So this is A union B union C. Now every element of A is an element of A union B. You can see in the case of A union B, 1 is there, 2 is there, 3 is there, 4 is there. So every element of A is in A union B. And we say A is a subset of A union B. And we write A is contained in, this is contained in A union B. So you can see this side is open. So A is in A union B. Now A union B is a subset of A union B union C. Every element of A union B is in A union B union C. So if A is a subset of B, it's an idea, B is a superset of A. So the relation between subset and superset. A is contained in B, and then we say B contains A. B contains A means B is super. B is a superset of A. We consider intersection of two sets A and B. First one was union. Now it is intersection. Intersection of two sets A and B is denoted by A intersection B. This is the symbol A intersection B. Now it is the set containing the common elements of A and B. So we are looking for the common elements and we form a set. For example, A is 1, 2, 3, 4. B is 3, 4, 5, 6. C is 2, 7, 8. A intersection B, common for A and B. You see 3 is common, 4 is common. So it is a set 3, 4. Now A intersection C, if you combine this, you see 2 is common. So A intersection C is 2. Now B intersection C, there is nobody who is common for B and C. So B intersection C is the null set. There is nobody. It is denoted by the letter phi. So this is the symbol for null set. Now we say B and C have no common elements and we say B and C are disjoint. Now A intersection B intersection C is also null because B intersection C is null. So with a null set, if somebody else comes, again the intersection is null. Now if A is 1, 2, 3, 4, B is 1, 2, 3, 4, 5, A intersection B, common part is A. Here the situation is A is contained in B, A is a subset of B, then the intersection is A itself. So this is a basic idea. 3. Difference of two sets. A minus B is the set of elements of A other than those of B. So in the set difference, we are giving importance to the first set A. Now, for example, A is 1, 2, 3, 4, B is 3, 4, 5, 6, C is 7, 8. Then A minus B. Now we take A and remove common elements of A and B. So 3 and 4 are common. So we remove. So A minus B is the set 1, 2. Now B minus A, we take 3, 4, 5, 6 and remove 1 or 2 or 3 or 4. So 3 and 4 are removed. So 5, 6. A minus C, you can see. A minus C. A 1, 2, 3, 4. C 7, 8. There is nobody of C in A. So A minus C is A. So we can see these two are disjoint. Then the difference is simply A. Similarly, C minus A is C. Now here is a notation. A union B is the set, this is a symbol for set, of X such that, this line indicates such that X is in A or X is in B, and or is denoted by this symbol. Now A intersection B is a set of X such that X is in A and X is in B. So X should be in both A and B. This is the symbol common elements. Now A minus B is the set of X such that X is in A and X is not in B. So we are giving importance to A and we remove all those common elements. So A minus B is a set of X such that X is in A and X is not in B. Dear students, my intention is to make mathematics as simple as possible. That is why I give small examples. Now in the later course of time, we'll be discussing more hard problems, giving importance to IIT type questions. Now for the time being, you understand the basic principles and go through the topics in your textbooks. I would like to ask you to copy this to your friends so that they also will be benefited. Convey this to your friends and see all obtain some important results and basic principles of mathematics. Convey this message to all of your friends. Best of luck for all of you. With prayers, thank you.